So we are taking few more questions and answer in software engineering. What is the use of DFD, data flow diagram, and explain the important concepts of data flow diagram. A DFD is used to show the functional view of an application domain, and mostly in the structured programming, we often use DFD. It shows all the important business processes and the flow of data between these processes. The key concepts here are the process represents some kind of transformation of data. So it takes as input one or more input, and after doing necessary processing it generates the output, and it is represented by a circle with the name written inside. So data flow diagram, in this we have data flow. A data flow represents the data in motion and is represented by an arrow, and the data flow represents the flow of data among the say processes, the stores, and the external agents. What about the data store? Data store like this. So this data store represents the data at rest. That means at the time of implementation, say it is represented by say database or file. Then we have external agent. The external agent represents a person, a system, or any other software which interacts with the system by providing necessary inputs and outputs. And graphically, it is shown by the rectangle. So how we can draw a diagram of a library management system? Say we are members, or they are suppliers. This is the LMS or library management system. So we have request for membership not available, cards plus membership receipt, receipt for issue of membership, the book not available, and the fine or return of book. Then the purchase order with respect to LMS and supplier, invoice, books, and payment supplier. What is SRS? Why it is important? List the characteristics of good quality SRS. SRS is the output of requirement analysis stage of the software development lifecycle. So it documents all type of requirements and constraints imposed on the end product. These requirements include the functional requirement and the non-functional requirement. Functional and non-functional requirement. And this document is important because it is used in all the successive stages of SDLC. The document is important because it is say a baseline for all the other stages. So any error which are introduced here will result in incomplete or bad quality product. The good characteristic of SRS can be correctness. It should be correct. The SRS should be complete, means containing all the requirements. Consistent means no two lines should give an contradictory definition. The unambiguous means whatever is written should be understood only or interpreted only in one manner. The ranking of importance means the prioritization may be done. The modifiability, it may be amenable to change. Verifiability means if we are able to every requirement what you are writing should be verifiable. That means you may be able to generate the test cases for it and verify with different means and terms. Traceability, that is every requirement should be traceable from other stages. The design should be independent and understandable by the customer. So people generally use the UML use case diagram in this case to make it more understandable by the customer. What is the difference between module coupling and module collection? Module coupling and module collection list different types of coupling and cohesion. So cohesion is the property of a single module and can be described as the glue that keeps the data element within a single module together. So we must aim for high cohesion while we are designing. Different types of cohesion are coincidental cohesion, logical cohesion, temporal cohesion, communicational cohesion, sequential cohesion, functional cohesion, and procedural cohesion. So coupling, on the other hand, is a measure of dependence among these modules, number of modules, dependence among them. So a designer must try for minimum coupling. And there are different types of coupling, which is content coupling, common coupling, control coupling, stand coupling, and data coupling. Then what are the different levels of testing? Explain in details. Level of testing. The different levels of testing are there, like unit testing, integration testing, and system testing. In unit testing, the unit testing is done to test the individual module of the software, and test cases are designed to test either the programming logic, that is we can do it can be white box, or functionality, say black box, interfaces, that is in a module. So unit testing is since individual module is being tested, white box techniques are used here, but I don't say only white box, black box can also be adopted, no problem with that. So whenever required, stubs and drivers are also written to test the module, which increase the cost of the testing. Then integration testing. In this, the module are systematically integrated and tested to find interfacing problem, protocol design errors due to global values, and input-output format errors. For example, different strategies are there, like bottom-up or top-down. In bottom-up integration, in this type of testing, the modules at the leaf levels are first tested, and then they are moved up in the hierarchy. Drivers are used in this type of testing at different levels of hierarchy, and driver is a program which accepts the test case data to be inputted and printed by the module to be tested. What about the top-down integration? So in this case, we start the topmost module in the hierarchy, topmost, and move down till the leaf module are tested. So wherever required, necessary stubs and drivers are required. A stub is a program which simulates the module called by the module to be tested. Big bang testing, sandwich testing. So in this, all the modules after unit testing, they are combined at one go. All these are combined, and the problem with this kind of testing is, debugging of error, interface not being well tested. Sandwich testing, this kind of technique make use of combination of both top down and bottom up. Then we come to the system testing. This testing focuses on validating the product with respect to the software specification. That is, validating with respect to the software specification. Now, techniques like function testing, using the black box testing, performance testing, and acceptance testing to be done by the user is done here to test the product. So all these include, in software testing, include the final black box testing, or any, if you are interested in going to the coverage also, you can do that also. But usually when we validate the software specification document, we do the black box testing, and the performance testing and the acceptance testing, that is beta and alpha, are done here in the system testing. What are the advantages of using testing tools? Explain in detail different types of testing tools. So there are various advantages of testing tools. First, they improve the productivity and quality of software development. They help us in identification of error, which are sometimes difficult and time consuming if you do it manually. It will reduce the testing time, of course, and it helps in running large volume of tests, unattended for number of hours. And automatic generation of test cases are there. Automatic regression testing can be done, and you can improve the productivity of the testers also. There are some other important testing tools, which are test case generator, capture, playback, and test harness tools, coverage analysis tools, test comparators, memory testing tools, simulators, and test databases. Define the reverse engineering, and what are the main objectives of reverse engineering. So the reverse engineering is the process of generating representations that are implementation dependent, starting from the code. So we start from the code. We want to find out this is the code. We want to find out the design, and with design we want to see what were the requirements. So it is opposite of normal forward engineering process, and the objective of reverse engineering is it helps to for us or companies to understand the complexities of the system, and it would help the analyst to generate useful loss information about the legacy systems, and also to identify the reusable component for analysis and future case, and also helps in generating graphical representation of the system from different perspectives like ER diagram, DFT, and class diagrams. And this can be used as a part of re-engineering process. Actually, reverse engineering is re-engineering or re-engineering plus forward engineering. So over a period of or reverse engineering is backward engineering, which is sometimes known as the formulation of coming back to the code from the requirement and then going again from requirement to the code. Over a period of time, modification made to the software also result in unexpected problems, so the anomalies can be detected using the reverse engineering techniques, what were there, and how to solve them. Write short notes on the following maintenance model, quick fix model, and iterative enhancement model. Quick fix model, this is the simplest model. This is the kind of patch fixing type. Used for maintenance of the software. In this model, changes at the code level are made as early as possible without anticipating its future maintenance problem. That is the just patching of or doing it, fixing that particular problem which is there. So this model is not suitable for large and complex software systems. It should be used if the size of the software is very small and it is developed and maintained by just one person. And also, if the customers want this fixing of bugs to be done immediately, one can use this quick fix model. In that, bugs can be fixed temporarily and parallel, and proper correction can be done. What about iterative enhancement model? This model incorporates changes in the software based on the analysis of existing system. Also, the complete document of the analysis is available before doing any changes. So, in case of any changes made, all the documents at different stages, that is the SRS, design document, and testing document, they're also modified so as to support the next change successfully. iterative enhancement model. What is verification? It is the process of determining whether the output of one phase of a software development conforms to that of the previous one. The output of this phase conforms to the output of the previous one, whereas this validation is the process of determining whether a fully developed system it conforms to SRS or the requirement specification. So while verification is concerned with the phase containment of errors, the aim of validation is that the final product should be error-free. Describe design walkthroughs and critical design review. A design walkthrough is a quality practice that allows a designer to obtain an early validation of design decisions related to the development and treatment of content, design of the, say, graphical user interface and the element of the product functionality, and designing the walkthrough, which provide designers with a way to identify and assess the problems early, whether the proposed design meets the requirements and addresses the project goal. And for a design walkthrough to be effective, it needs to include specific components. And we have guidelines highlighting these key components, and using these guidelines to plan, conduct and participate in design walkthroughs, and they may increase their effectiveness. So these are, first you have to plan the design walkthrough, get the right participant, understand the key roles and responsibility, prepare a design walkthrough, use a well-structured process, review the critique product, not the designer. Review do not solve problems, they only surface the problem. So the purpose of critical design review is to ensure that the detailed design satisfies the specification laid down during the system design. And the critical design review process is same as the inspection process, in which a group of people get together to discuss the design with the aim of revealing the design errors or certain undesirable characteristics of the properties. Explain the relationship between time and cost. See, in software project, time cannot be freely exchanged against the cost. That is, such a trade-off is limited by the nature of the software development. And for a given organization developing software of size S, the quantity obtained is constant. The development of software of size S, the quantity obtained is constant. That is, k to the power 1 by 3, td to the power 4 by 3 is equal to s by c. What it means? This is what we are talking about, the time and cost. So this is, we raise power by 3, then k, this td power 4 is constant for constant size of software. So compression of the development time, that is td, will produce an increase in manpower cost. And if compression is excessive, not only would the software cost more, but also the development would become so difficult that it would increase the risk of being unmanageable. Write short notes on configuration management and decision table. So configuration management is basically the change management, a document control kind of thing, and it is an umbrella activity. So due to several reasons, software changes during its life cycle. So as a result of these changes made, we have multiple versions of the software which exist at one time. So these changes must be managed, controlled and documented properly in order to have a reliable system. So configuration management helps the developers to manage these changes, and systematically by applying the procedures and standard and by using the automated tools. And though these multiple versions of the software exist in the tool repository, only one official version of the set of project components may exist, which may be called as a baseline. So the different component of the baseline, these are called configuration items. And some examples of configuration items are project plan, SRS, design document, test plans, and user manuals. So a group of people constitute the configuration control board, CCB, which controls the changes to be made to the software. So whenever some changes are to be made, the following steps are to be followed. First, we need to submit the change request along with details to CCB. Then CCB assesses the change request after proper evaluation. And depending upon the request is either accepted or rejected and can be deferred for the future assessment. And if accepted, proper plan is prepared to implement the change. And once changes are made after validating by quality personnel, the configuration items may be updated. Some popular configuration management tools are ClearCase, Visual Source Safe, like this. Then we come to the decision table. So when the process logic for a process involves multiple conditions, it is very complicated. So it is not advisable to use the structured English. Instead, you use the decision table. So main part of the table are condition stubs, action stubs, and roles. So condition stubs list all the conditions relevant to the decision, and action part lists all the actions that will take place for a valid set of conditions. And finally, this is the rules part of the table specify the set of conditions that will trigger a particular action. So we'll see, this is a table. So you have these conditions and actions. So these are rules which are applied. So from this table, it is clear if conditions say 1 and 3 are satisfied, action 1, this action 1 will be triggered. If condition 1 and 2 is satisfied, action 2 will be triggered. If condition 3 and 4 is satisfied, action 3 will be triggered, like this. So these are a few more questions on your software engineering. We'll be taking one more. Thank you so much.